IoT with Azure behind the scenes, right? Now, this is an interesting topic. We all know some things about IoT from our college curriculum, and we also know what Azure is. It's a very popular cloud platform. So, what we have done is we have basically prepared a meetup which will teach you how you can create your own system from scratch and also learn a few things about IoT services that are provided by Azure, right? So, okay. IoT. Now, IoT is an intriguing topic in itself. It is something that is probably not heard so much in your surroundings, but IoT is pretty common in our lives. Now, first of all, how many of you guys know what IoT is? None? Okay. What is IoT?
So IoT is Internet of Things where things are now not just things, they are more intelligent than that.
Okay.
And they can communicate with the internet. They have their own network where they are connected to each other. And they are more intelligent, so they can do few small tasks on their own.
Yeah.
That's all.
Exactly. So that's pretty much the gist of it, right? So in this meetup, we'll be covering the introduction to what IoT is and how Azure works, and also the configuration process and a demonstration for you guys, right? So I'll be starting off our meetup with the introductory part. So as we know what IoT is, but I'll give you a basic explanation of it. IoT is basically an ecosystem of devices that have sensors embedded within themselves, right? Now, what do these sensors do? These sensors will basically collect all the telemetry data in the surroundings and send it to an edge device. As you can see, we have multiple devices connected to a laptop. Let's assume this laptop is a server for now, right? So all these sensors will collect data like audio data, video data, temperature, or motion, all these sorts of data, and it will send it to an edge device where it can be stored temporarily, right? Not for permanent storage, but some place where it is used as a bridge to connect it to a server or a cloud platform, right? That's what IoT is. Now, let me give you an example of what IoT is in real life. We all know Mark Zuckerberg, right? The godfather of social media. Well, he had a plan in 2016 where he wanted to create an AI called Jarvis. You all know Jarvis, right? From the popular series Iron Man. So what Jarvis will do in Mark's house is basically create an environment where he can run his whole house, automate his house with a few commands. So let's say I'm sitting in my living room and there's a lot of sunlight coming in, right? I don't want to get up and just pull down the curtains, or I don't want to dim the lights by getting up, right? So what I'll do is I'll just wave my hand twice or something like that, and the lights will dim themselves or it will turn off. This was the basic idea of Mark Zuckerberg, right? How to create a system which will basically automate all these daily tasks. Well, Jarvis is a bit different, of course. It's very high level. He wants to automate his whole house, right? That's not going to happen at our scale. But that was the basic thinking of how we can integrate IoT in our lives. Now, how many of you guys know any IoT devices or any IoT environments that you work with? Anyone? They're pretty common actually. We all have phones, right? Our mobile phones. We all use them for GPS. We use them to even measure our heartbeats, the flagship ones, right? So all these devices are basically IoT devices that will collect your data, and then you can do things with that data, right? You can measure your heartbeat. You can measure how much motion or how many steps you walk, right? So these are things that are basically simple IoT devices. Now let's talk about environments. I mentioned IoT environment. Let's say I have a house. Now I have a few CCTV cameras surrounding it. How do I make sure that all that video is stored somewhere, or where I can view that data, right? So we have routers and small systems or softwares that collect that data, and we can basically view what's going on surrounding our house, right? So that's an example of IoT environments. Now, okay. Now, after all that, how does IoT work with Azure? Where does a cloud platform like Azure come into play with IoT devices? Now, IoT devices have that capability they are those smart devices that will basically collect data and they relay the data somewhere. But where does that data go? You need an edge device for that, right? Okay, now we have our data in that edge device. What's the next step after that? Do we just send it to some server for storage, or do we send it somewhere for further processing? Well, what if I told you that you can do all that at just one place? So what Azure does is Azure will provide you IoT services where you can store your data in a SQL format, or you can basically process that data further on, even visualize it, right? Uh, Azure with IoT will also provide you a bi-directional way of communication. Now, we often think, okay, so I'm sending some data to a server or to a cloud platform or to my Raspberry Pi. What happens next? There's no way of sending a response back, right? You get that data and that's it. So what Azure will do, it will provide you a form of bi-directional communication. Of course, security is a big part as well. Azure is very secure, and you will be pretty much sure that your data is not just being sent somewhere without any protection. Okay. So now, Raspberry Pi and Arduino Uno. These are two very big names in the tech industry. So this is a Arduino Uno right here, and I won't show you the Raspberry Pi for now. It is actually configured, and let's not mess with the wires for now. You can have a look at it after the meetup is done. Now, this chip right here is the size of a credit card, right? What does this do, or what does a Raspberry Pi do? How do we know what kind of system or what kind of chip we'll need for our project, right? So, so these are some of the key differences, but I'll tell you the actual use cases of these two chips, right? Now, let me give you a comparison. First of all, Raspberry Pi is basically a laptop, right? It's a laptop, it's a MacBook, and the Arduino Uno is a calculator of sorts, right? Now, let's say if I come home and I want to watch some videos on YouTube, right? So I want to watch some gaming videos on YouTube. I want to play some music. I'm going to go on my laptop, right? I'm not going to take out my calculator to do all that. So the key difference between these two is that one is very powerful, one is not that powerful, but they have similar use cases. That's why I say that these two chips are very, very different, yet very similar, right? Okay, so let me give an example of Raspberry Pi. Let's say I'm at home and I have a TV, a normal LED TV. It's a 32-inch TV. It's not a smart TV, right? It doesn't have Netflix and Prime and Hulu and all sorts of OTT services. How do I make that TV a smart TV? Now, with a simple package installations and a few lines of code, you can make your TV a smart TV with just a small chip, right? Now, another use case of that, right? I'll tell you, if I want to store some data temporarily, I'm outside, I have, let's say, about 20 GB of data, and my laptop doesn't have the storage. I can turn my Raspberry Pi into a storage device itself. Another fun one, we all know video games like Super Mario, right? And Contra. These are very popular games in their times. But we have heard about the emulators, right? We all know emulators? Okay. So for those who don't know emulators are basically where you can program a screen to run games from the PS1 or the Nintendo, right? The old school games. Now I can install a few packages into my Raspberry Pi, and I can make sure that my Raspberry Pi will emulate all these games onto a screen, right? You can even use your PlayStation controller or your Xbox controller for that. Now, after understanding what Raspberry Pi does, let's move on to the Arduino Uno. Now, the Arduino Uno is a whole different ball game, right? Arduino Uno will not do all these super crazy high tech things, right? Even though they are not that crazy, but it's more practical. It's more hands on. You're not going to use, as I said again, you're not going to use your calculator to watch YouTube videos or something like that, right? So what the Arduino Uno will do is that it will take some input. It will take some input. It will take that input, process it, and then it will do a function on the other end. It will output some functionality, right? It will do some hands-on work, some practical work. Now let's say I'm sitting at my desk, and the curtains, again, the example with the curtains, right? The curtains are not where I want it, right? Or my colleagues want the sunlight to come in, whatever example, maybe the air conditioner is too high, right? So what I'll do is I'll create a system using the Arduino where it will automate all that. It will automate groups, even multiple devices can be connected to each other. I can basically use my hand and make sure that the curtain is going up or down, depending upon that, right? So that's a more hands-on approach. Now let's say about a garden. I have a garden. Now I'm not home very often, right? I have my job, I have to socialize, all these things, right? Now when I go home, I want to make sure that the water is seeping into the soil at particular times when the soil is dry. So I'm going to use a humidity sensor which will connect with the Arduino. So once the sensor detects that the soil is not very moist, right? It will basically send that data to the Arduino. The Arduino will have some code that will execute, and the water will start running. Right? You can learn about this example on YouTube. It is actually very popular. So now we know these two use cases, right? We can see how they are similar yet different. It's all about optimization. It's all about, okay, if I want to go downstairs and walk to the next block, I'm not going to use a car. I'm not going to use my two-wheeler, right? You can just walk there. So it's all about using an appropriate amount of power and being efficient. Now, after all this, does anyone have a question regarding these two chips? No? Okay. Has anyone worked with them? With Raspberry Pi or Arduino? Okay, of course. You have? Okay, so how was your experience? It was good, right? So did you create something?
Yeah, I worked it for robotic arm.
Sorry?
I worked it in a robotic arm setup.
Okay, exactly. So you use the Raspberry Pi, right?
I used Arduino instead of Raspberry.
Okay. So that's another example, right? Yes, sir.
Question: what is the hardware comparison between these two?
Okay.
Is one more powerful than the other? Memory, processing.
Yeah. So the Raspberry Pi is actually very powerful compared to the Arduino, right? It also consumes a lot of power. So what the Raspberry Pi has is it has components that a simple CPU will have. It will have the SD card slots. It will have the HDMI ports, the USB ports, right? It will have all that. It will do all the functionality that your simple low-end laptop can. It's not going to give you a throughput of, let's say, 3.5 gigahertz or 4.5 gigahertz crazy gaming laptop throughput, right? But it will do the job. On the other hand, the Arduino, as he suggested, that it was used in a robotics setup, right? So what it did was it will take some input and it will do some action, maybe move the robot's arm, but it's not that powerful. You're not going to make a whole enterprise level system using just a simple Arduino chip, right? So in terms of power, I would say Raspberry Pi is better. But if you want more hands-on and practical approaches, you have to use the Arduino, right? Now coming on to the key differences between these two. The Raspberry Pi has an OS that is Linux based. Now we all know Linux, right? We all know what Linux is. So if you're already familiar with that, it will be easy for you to get into Raspberry Pi and how it works, right? Now, coming on to the Arduino, it's not really based on an OS, right? You write code in C++. You execute some functions in C++. You want to have some sort of code that is working properly and which will do some sort of action and help you in your project, right? Now, after all this, you're probably wondering, okay, so these are all the key differences between these two. One's a microprocessor and one's a microcontroller, right? So, does anybody know what a microprocessor is or a microcontroller is? Okay. So, microprocessor is basically something that has all the components of a simple CPU. Okay. And a microcontroller is something that's not a CPU in itself, but it has everything embedded within itself. So let's say if I'm building a CPU, right? I'm going to need a Raspberry Pi? No. I already have a CPU. But if I'm going to build this whole system component by component, I'm going to need the Arduino parts, right? So after all this, you can probably see how one is used for one part and one is used for another part. One has a more hands-on approach and one has more software side approach. Now, at the end, you're probably thinking, okay, so what now? How do I decide what chip to buy or what chip to use? So it basically comes down to what your project is, right? What your use case is, how many chips you require, or how many uh, IoT devices that you want to manage, right? So it all comes down to that. Now, after all this, I'll give you a quick demo of how we created our system. So, okay, so we basically created a system where our temperature sensor will detect the data and it is connected to a Raspberry Pi itself, right? Now, okay, so it's already running for you guys. As you can see, the actual sensor is actually dipped into water right now, so the temperature will change accordingly. Simple, right? Now, this is actually a very vague representation of what we actually did, right? About the effort that we put in. So you're probably wondering, okay, so now I know what IoT is, I know how Azure will work with IoT, I know the examples, I know the use cases. Now, how do you configure that system for yourself, right? How do you go home, you buy the necessary components, or how do you know what to do next? So for that, my colleague Ishan will be telling you how to configure your own system, right?
Yeah. So thank you, Jay, for giving the basic introduction of our system. So let's say if you are not very familiar with the Raspberry Pi thing, and you want to build a system from scratch. So I will discuss about it in a few steps. So basically, we have divided the whole process into 4 steps. So yes, so in this configuration, we will need a few hardware components, including a Raspberry Pi, few jump cables, a sensor, which we will be using as a temperature sensor, and a power cable. Right. So we have divided this whole process into 4 steps. Like first is OS installation, then we will connect the Pi to the internet. Then we will see how the Pi is working in on our system, right? And the last thing is connecting the sensor to record the data. Yeah. So here is the basic anatomy of our temperature sensor, which we will discuss later. So the sensor will have 3 output cables. One is VCC, so which is basically for like giving the power to our sensor. One is for ground, and the last one is for data. So data will just interact with the Pi and send and receive the temperature data. Right? So let's start from beginning. So So first, we will need few hardware things. First thing is we will need a SD card reader. So anyone know why? What is the main purpose in SD card in our project? Like when we are using Raspberry Pi. Okay, yeah. So basically, Raspberry Pi is an mini CPU, right? So what Raspberry Pi will need an OS to perform certain operations. So we can use an SD card and install an OS, and then it can be connected and be used. So for that, we will use a tool called Raspberry Pi Imager. Yeah. So here is the tool. Uh, the Raspberry Pi can handle almost all kinds of OS, like whether it is Linux based or Windows based. But as they are providing an default OS for Raspberry Pi, which is Raspberry Pi OS, so we will prefer using that. Right. So here are few options available. Uh, OS Lite, full versions with desktop or without desktop, and legacy. So in our case, we used the 32-bit of Raspberry Pi OS. Next step would be choosing the storage. Right? So as our system currently is now connected and working, we cannot see the storage as our SD card. So in this step, you can select the storage and start the writing process. So generally, it might take around 10 to 15 minutes to write down the OS. So after completing this step, we will need to connect it to a stable network. So for that part, there are few methods like we can use uh, inbuilt operations, and in our case, we will be using SSH handshake method. So anyone have any idea about SSH? No? Yes. Yes. So for that SSH handshake, we will be creating a file called SSH. Here you can see that, and we do not have to put any content in that file, and we will create a configuration file. So this file will have few. So okay. Yes. So this file will have few basic setup things like what is the SSID of our Wi-Fi, what is the password, and what kind of authentication we will need to connect the Pi to the network. So yeah, after creating these two files, we will move these two files into boot folder, boot partition of the Raspberry Pi. So here I will show you the boot partition. As our system is running right now, we might not be able to see those files because those are the hidden files. So here is the boot section of our Raspberry Pi. So we will paste those two files in this folder. So what this will do, it will just connect the Raspberry Pi to our network by itself. So the first two phases are completed as here we discussed. So till now, anyone has any questions? Okay, so next we will see how we can display the Raspberry Pi on our system. So for that, in our case, we used a protocol called XRDP. So what XRDP protocol will do? It will just remote desktop protocol. You might have heard about it. Like when you are working from home, or you might be using someone else's PC. You just type that person's IP and you can connect directly into their system, right? So here we will use a tool called Putty. So yeah. So next, after installing that Putty, we will configure a boot file. Like here, we will move to the etc folder and open a file called DHCPCD. So this is a Linux file which is used to connect or configure the network part of the OS. So here we provided a static IP, then we provided the default router and DNS of our network. So when we are working with Raspberry Pi, until we give a static IP, it might be fluctuated. Like after every boot, it will get a random IP address. To avoid that kind of situation, we can give a static IP and use it that way. Okay. So next, after installing the putty thing, we just enter the IP address which we have given and load it in that. So first, if you are using it for the first time, you might be thinking like what default username or password we enter. So for that thing, we can use default ID password which is Pi and Raspberry as login and password. Right? So here I have configured it and yes. So here I have been in the GUI part of the Raspberry Pi. So here I will need to install Rdp Protocol as it is not pre-configured in our system. Right? So I will perform. It is. I cannot zoom it right now because it is a GUI. So basically, I will just perform one command sudo apt-get install xrdp. So if you guys are familiar with Linux, this is just a basic command to install any other dependency. So after performing this, it will install all the required files in our system. Okay. Yes. So we have installed the XRDP protocol in our system. Now we might be able to use the RDP from our system. So here I will use the Windows default tool called remote desktop connection. I will put the IP address which I have provided and will connect. So here is the XRDP gateway which I will be using. We will enter the username and password, and here we are inside the Raspberry Pi. Here it is how it will be look like a normal system. So it has not many uh, tools or folders, etc. It is just a basic configured Linux system. Yes.
So whether it is those all IPs are internal IPs.
Yeah.
Offline. What in case if there is a outside IP, can we use the public IP?
Yes, you can configure it according to your needs. Like you can also use any random IP from there are few websites. You can generate IPs which is not used.
So
So
is there required special configuration for that?
no, we don't need that. We just have to give a static IP like to avoid those fluctuations when we are trying to connect after every. Yes, so here we are able to see the basic desktop of our OS. So we can perform all the things like browsing internet or opening files, terminal, etc. So we have completed the first three phases. Anyone have any questions till now? No? Okay, fine. So next part is uh, we will create a circuit to connect the temperature sensor. So here we have used DS18B20 sensor. So here you can see the basic diagram. Like this part is a Raspberry Pi. We used few GPIO chipsets and connected it to the breadboard. So here is the breadboard, and here is the jump cables. I will pass on at the end of the session, and you can see it by yourself. And here are few other sensors as well. If you want to go through it, you can do it at the end of the meetup. So here we have connected the sensor, and here, as you can see, R1. So does anyone know what is that thing? Sorry. Yes. So that is resistor. Like we can use between 3.5 to 10 kilo ohm of resistor in our case. Okay. So after completing this setup, we will check like whether that uh, specific sensor is connected to our system or not. So here, first thing we will do is we will open up. Just a minute. We will open a boot partition of our system and open the config file. And add a line here. So what this line will do, it will allow the external sensors to be used in our Raspberry Pi. So it is not a compulsory step like a few OSs are use it by default, but in our case we had to do it manually because we were facing some issues, right? So after doing this, we can move to a specific directory. Like here, I will again open the putty thing, and I will move to a specific directory Just a minute. So basically, as it is a terminal, I am not able to zoom it. So just I will explain it verbally. Like I will move to system directory. Inside that bus and W1 and devices. So it will return me a list of what sensors are connected and what is their address of hardware address of that device. So it is returning me a 28 dash something kind of value. So that is our temperature sensor. I will move to that folder and it have few driver configurations like what files are present and what are the data, etc. So I will use a cat command and it has returned me a specific value. If you are able to see that there is something written like yes. So it is just a confirmation from Raspberry Pi that the sensor is connected and working properly. So next we have created a uh, file to measure the temperature. So this is a Python script. Basically, what it will do, it will just record the data and send it to the Azure server, which my colleagues will cover later, right? So here is the connection string. This part will be described in deep by my colleagues. Right? So here it will read in this part. Yeah. So in this part, it will just read the temperature and it will be initialized and then it will be sent to the server. So as you can see at here, there might be some fluctuation in temperature. Like I am holding it in my hand right now, and according to that, it will react differently. Right? So till now, we have learned that how to create a circuit, how to record the temperature data, and how to send it to Azure. Like so, you might be thinking, what we will do with this all this data? Like how will we consume this telemetry data? So for that part, my colleague Himanshu will describe in detail.
Okay, thank you, Ishan. Good evening, good morning, everyone. So now Ishan has described the configuration part. So now, anyone have idea about what is the Azure? Yes. So basically, Azure is the cloud computing by the Microsoft. So, any have idea about what is cloud computing and which type of service provided by the cloud computing?
software as a service, platform as a service.
Okay. Okay, there are mainly we have used mainly three types of services, cloud computing services. So basically, first is the software as a service, second is a platform as a service, and infrastructure as a service. And there are many other services are provided by the cloud. And first is like a software as a service. So any idea about what is the software as a service and how it will be used? Okay, so software as a services provide the ready to use that services. So we have to only worry about the data and authentication part. So we have many examples like Gmail and Outlook. So we have to only worry about that data and ready to use that services. Okay, so next is the platform as a service. So where we have to develop that service according our requirement. So we have to develop the services and coding and or else. So there is a platform of the platform as a service like Heroku and Jenkins where we have deployed our projects. So this is the platform as a service, and last is infrastructure as a service. So it will be provide the physical resources like VM or storage and networking. So that type of thing in the infrastructure as a service. Like these all services provided by the Azure, AWS, and Oracle. So anyone have question regarding this? The next. So now, anyone have idea about Azure IoT services? How many services provided by the Azure? Okay. So Azure IoT services are many types of services provided by the Azure. So we have mainly three services mainly used in the IoT devices. So for first is Azure IoT Hub, Azure IoT Central, and Azure Sphere. So okay. So first is the Azure IoT Hub. So basically, Azure IoT Hub is a one type of platform as a service. So where we have developed according our requirement. Okay. So this is the IoT devices. So we have hosted the devices into IoT Hub. So it will be like we have to status about our IoT devices, how many IoT devices are working, or and also we have enabled and disabled the IoT devices. So now IoT devices are hosted. So we have to use another services for the monitoring and inside the that data to the showing and monitoring that type of thing. Like other services like Power BI or Steam analysis and that. Anyone have a question for the IoT Hub? No. IoT device, Azure IoT Hub is provide the hosting environment for the IoT devices where we have host the IoT devices in, and also IoT devices provide the one IoT Hub. We have hosted 1 million or up to 1 million IoT devices in one IoT Hub. Host means that we have getting the data from the devices and we have to use into another service using another service IoT service. Hosting this.
Actually, IoT Hub, like we have a device, right? Currently, we have temperature sensor. So, if we have a Azure will provide one environment, right? We virtually host the device to the IoT Hub virtually. Actually, in a script that Ishan has previously shown, we have a connection string, right? The connection string will be for the particular device that we have host in the IoT Hub. I'll give a demo for that so it can be more easy. Yes, particular devices, each device has a different connection string. So connection string has a recognition of our device. We can virtually host that device and we can connect with IoT Hub through connection string.
So basically connecting to the
Yes.
hosting storing the data.
Yes. Not storing part. It's just the part that we host the data and we host the sensor and configure it. Like we want to disable the sensor. So the configuration part will be on IoT Hub.
So any other question?
Can we have an interdependence also configured in the IoT Hub?
Sorry?
There are say two devices
Huh.
collecting the data from two screens. And then we want to sort of build a relationship between the two devices. Can it also be configured in the IoT Hub or do we need a separate platform?
No, we just need separate.
Separate IoT device. So next is Azure IoT Central. So Azure IT Central will provide the like a software as a service. So where we have ready to use templates. So that template provided by the IoT Central, which is like a industry standard templates. So basically there is the IoT devices. It will be connected with the IoT Central, and in IoT Central we have to use the templates, and according templates we have to develop our services. So okay, so this is the IoT Central application. So where we have many types of templates like in-store analysis, water consumption monitoring, and connected logistics, and that type of template will provide by the IoT Central. And also we have built that templates according our requirement. So that will be provided by the IoT Central. So last is Azure Sphere. So basically, Azure Sphere is one type of end-to-end IoT solution. So this is more secure IoT device, secure IoT services. So basically, we have a IoT device. So where we have to put a Sphere MCU like microcontroller unit. So we have to put that in the Azure Sphere IoT devices, and also we have to install the Sphere OS into our IoT devices, where we have monitoring the data and all those things like locally, and like embedded system like. Okay, so like example like we have washing machine, so we have monitoring like we have to timer set, and all those things are by in. So this is the services so mainly used in IoT services. So anyone have a question regarding this?
Do we have similar kind of services in AWS and GCP?
Yes, it will be provided, but we don't have any.
Do you have any idea which one is mostly heavy?
No. Okay, so this is the services. So in our case, we have using IoT Hub Services. So how to configure that services, that will be covered by Azure.
Okay, thanks, Himanshu. So currently in our project, we have a use case to sense the temperature data, and then I want to store the data or I want to show the data on some place. Currently, IoT Hub, that explained by Himanshu, like IoT Hub is a place that we host the data. Sorry, the hub we host the temperature sensor virtually. Now, what if I want to use the data to some other place? Like I want to show the data in in visualization way. So we use a Power BI service. Power BI service is basically Microsoft has provided one service Power BI that we visually graphically show the data. So if I have a Excel sheet of data, I cannot analysis based on the Excel sheet. So for that, Power BI is a tool that provide a data to we can see the data in a graphical way. And in our use case, we need to stream the data in a real time. Right? The important part is real time. We want to sense the data and show the data in a real time to the some place. So I'll give a data. I'll create IoT Hub. I'll create one other service that streaming the data and show the data in some place. So for that, so Azure has provided one other job, a stream analytical job. Do you have any idea about that job? Okay. Okay. So what it does is we just need to give input. Like currently what we have a IoT Hub. We have IoT Hub, we have a device that it's hosted in the IoT Hub. Now we want to send the data, or we want to receive the data from some place. So what it will provide a bridge from input to output. From output in our scenario we have a Power BI. So we need to add one IoT Hub in the input part, and an output part we need to add our Power BI. It will, in a real time, it will stream the data, fetch the data from the input, and send the data in output part. Okay. Uh, One more thing, we can host up to 1 million devices in one IoT hub, right? But and also in streaming analytical job, in one output, one input, we can add multiple outputs. Like what if I want to store some data? Like I have a real-time data streaming process, right? So I want to store the data and also I want to show the data in a graphical way. I can do that. I can add multiple outputs with a single input. For that process, anyone have any idea? Like, how can I do that? Or have you anyone that created any kind of Azure service or any service in the Azure? Okay, let me create it. Let me give a demo. Okay. Is it visible? So, if you know about the Azure, Azure is a tool like we have used a portal to create or consume the services. Right? But if you have any, if you want, if anyone have any others configuration part, like I want to have an idea like what is the cloud, what is the shared part, right? So we can use the create. We can create a service. We can consume the service through cloud shell also. We can create service, consume service, all the things that is possible with the portal. We can also do the same thing with cloud shell. Okay. Let me. Okay. For that, I'm giving you a demo of IoT Hub first. So for IoT Hub, I need to create IoT Hub first. It's just a simple process. We just need to click on the create, and it will create IoT Hub. I'm not creating it now. I have already created it. So this is the simple service I have created it. Now question is, how can I add a devices? Actually, requirement is to host the device, right? On the left side of okay, on the left side of pen, we have a device options. Let me click. Currently, we have added a device which is Raspberry Pi. We can add multiple devices if we want. For clicking that part, I'm not creating it now. Okay. So by means of configuration part, here we can see a primary connection string is there. We utilize this connection string to communicate with the IoT hub to our devices. Currently, we send a data, like we configure a program in Python in the Raspberry Pi, right, to sending the data. So for that, we have used this connection string to communicate the device sensor and send the data to IoT hub. We can enable it, we can disable it, or one more thing, it's a bidirectional process. Bidirectional means we can send the data to Raspberry Pi to IoT hub, and also we can send the data cloud to device. It can be possible. Any questions on that part? Now, other part. Okay. stream analytical job. The purpose of creating it, I'm just utilizing I want to stream a real-time data and send the data to some other services. For that, stream analytical job will use as a bridge process. Okay. Screen is visible for everyone, right? On the left side part, as I can see, we can add input, we can add output. Right? So for input, we can add three types of stream inputs. One is event hub, one is IoT hub, and one is block storage. So currently, for our purpose, we have used IoT hub. We can also use block storage, like it's up to our requirement. We can use block storage also. We can use event hub also. Right? And for output part, these types of services we can utilize it on output part. We have a Azure function, we have a Azure Synapse Analytics, block storage, event hub, Power BI, service bus, and SQL database. We can also use these services on output part. Like if I want to store the data, and if I want to in parallelly, I want to show the data on a graphical way. So I use SQL database and Power BI part. I can add two outputs on that part. I have already created it. Okay. So question is, I have added the devices on IoT Hub. I have created output. Now what? How can I know it can be like there is a data, there is a device, or there is output? The communication, how it can be happen? Communication is the key, right? How can I know which data will go to that output? And how can I know which data I need to optimize, or it can be pre-processed? If I can do, I want to pre-process the data and then I want to send the data to output. Then it can be possible with the query part. Zoom in. Okay. So as you can see, we have an input and we have output. For input part, we have used IoT Hub. For output part here, we have used input part as a IoT Hub, and output part we have used Power BI part. We can add up. We can add many more. Like if we have a SQL storage part, right? So I need to add these two outputs here. So based on our query, this is similar to a SQL query. We just perform the query and that's it. It will, based on our query, it will send the data to output. Select star into a output part from the input part. Input part we have IoT Hub, output part we have a Power BI. So how can I know like what types of fields I'm getting? On the left, on the bottom side, we are getting these types of properties. If we want, then I can download the sample and see how many types of how many types of columns are there. If I want, if I have two IoT sensors, right, in IoT Hub, I can like sum, or I can average the data. I can average the temperature of multiple sensor, and then I just want to send the data to output. Then it can be possible with this query. You can write down the query based on your need, and then send it data and filter the data and send it to output. So, any questions on the process or any doubt? Yes.
You have different kinds of devices. They might be sending data in different formats.
Yes.
Different formats, different amount of data, right?
Yes.
And so, how does all the data that processed and get into the database? So, see, once data is in the database, things are easy. I mean, it's structured data.
Yes.
You can query. But what comes to IoT devices is not structured. Like, it could be CSV files or I don't know how they transfer. Somewhere you kind of process the data and put it in the database.
So actually for that we can also cast the properties. Currently we have a temperature, right? The temperature is coming as a decimal or as a integer part, right? We can cast that as a string or anything. So we can
See this slide, but okay, very basic question.
okay.
When you connect a device to your IoT hub,
Yes.
how does the data get transferred? I mean, what is the format? Is it JSON? Is it
Just-
CSV? What?
When I create that input part as a like when I create IoT when I add IoT hub in the stream analytical job, that time I'm getting an option like what is the format CSV, JSON. Based on the selection part, I'm getting the data.
Now, suppose I select JSON.
Yeah.
Now, IoT hub has to know that what are the fields. JSON is not simple comma separated string.
Yes.
Even in that, you have to say that comma is the element. In JSON, there could be structure.
Yes.
How do you tell IoT hub that this is the structure that you can expect from the
No. If we pass currently from the script part, like Python part, if I send the data in a CSV format, right? So I'm not able to get the data. We need to pass the data in the JSON format because we, at the time of creating input part, we need to set a formatting of data. Currently, at that time we set the JSON, then we need to give the JSON data for the particular service.
you say that this is JSON data coming in.
Yes.
But what is the format of the JSON?
It's not predefined, predefined format. If we currently our temperature sensor will send a data of temperature only, but if we change the sensor, and if the sensor will send the data of humidity also, and we can get the data of humidity. Okay, so if you can see, currently we get temperature part only, right? We don't get a humidity sensor. But if I am having a sensor and if sensor has a property of humidity, and if I connect it to IoT hub, and then I can see I'm also getting that humidity field also in the output part because I'm using star mark for now. But for our real purpose, if a sensor has a multiple like 200 of properties, so do I need all the properties? No. For the output part, for the storing purpose, we use some properties that we have used only. So we filter the properties based on our requirements and then utilize it. One thing, currently we don't store the data, just streaming the data for our purpose. If we have a requirement, then we want to store the data, then we can store. We can also store the block storage, right? We can store the data in block part. Okay, we can also.
So the question is that where in the IoT hub you say that okay now I have changed my sensor.
Yes.
You will now also get humidity data. For example,
Yes.
IoT has to know that now humidity data is also needed.
Yes.
Where do you find that?
Okay, so we have a query like in IoT Hub. here. I'm getting the properties of, if I select star from this device, I'm getting it. Or if I don't want to use this, and then I want to just directly check on the stream analytica, so I can do that. Yes.
Let me explain that. So in database, we are not defining any particular columns,
Yes.
right?
Yes.
We are just storing the random the data which we are getting, storing in the block or some serious column.
Yes. Yes.
So how you will then convert those unstructured data into the structured data? Suppose I want to create some kind of analytics and creating some graph,
Yes.
then how you will do that?
So currently we have a star mark for now, right? In the query, and we are getting event process UTC time. Right? So I just need to use same thing. Like if I use a SQL part and cast the field, right? Like cast as a string. Right? So I need to make a query like that for here on the star mark. If I like, I'm getting many more. Like if I sometimes I'm getting null record also. So I just use like query like that, not equal to null or all that or all kind of data, query. If I use this kind of query and then send the data, then it can be in format part.
Is there any background to create some Python script, some algorithms to get this data and convert it into structured data?
No, for that we need to use this SQL part, this query part also, query part only. For this query part, we need to modify based on our requirement. If we have multiple kind of like currently we use temperature as a decimal part. But if I want string, then I can cast it. That's it. Previously, we just first we cast it, then I need to run the stream analytical job, then I'm getting
Let
it.
me give you a simple example.
Okay.
So suppose I have a sensor in my car
Okay.
which is detecting a speed limit.
Okay.
I have sensor in my home which is detecting a temperature.
Okay.
Now both the sensor and devices are connected with my Azure cloud IoT services,
Okay.
and both are sending data to the same cloud service. So
Okay.
now car devices data and the home device data not getting matched,
Match, right.
correct? But suppose I have 15 cars and I have 15 sensors, and all are sending the data to my Azure cloud.
Yes.
And I have 5 flats, and all the data is also sending to same. So now I want to check which car crossed the limit. Suppose I set a speed limit of 100. So, and I want to get an alert. Like if it is crossing the limit of 100, I get to notify by SMS or something. And if my temperature, home temperature is going down below this or going down below above this temperature, then I will get also notification. So all this because in some case I need some script which can extract the data, identify whether this is working or not. So such kind of
Before the lecture, you just need to like trigger on some part. Like we use some kind of query. Query means we just need to kind of pre-process the data. Then based on the actions or based on the output, we need to perform some actions. So we use other services for that.
I think
Like-
especially that once this query suppose device has full ID,
Yes.
right? When you are running to run this query, is there a process which will run this query and extract what is the current temperature,
Yes.
right? The current temperature is about 30. It will,
We need to
what is that logic?
we need to write that logic. Like if we familiar with the SQL query, we need to write like if this column greater than this thing, right? Then only we need to send the data to output. This is the streaming process. For triggering part, we use other things like event hub. Okay, just confusing part. We have other services also, like for triggering part. We have used Azure functions for some process. Based on some query, we need to perform some different actions. Or if you just mentioned like if I am having more than this speed, then I need to send a email or you need to some identity some kind of alert, and I use different service that provided by Azure. For this purpose, we use streaming part. Currently, we have a sensor of temperature, right? So based on the temperature sensor, we use streaming process. Okay, so if we have a UV sensor, right? So based on the distance or based on some logic hour, it will be perform some different action. So we don't use a stream analytical job for that. Use some different process. So we use some different service. Okay.
So now suppose I have 10 lakh devices
Okay.
and which are configured on same cluster
Okay.
with single instance. So suppose if my server capacity is not that much high to handle the 10 lakh requests in a single go, correct? So I will making it as a multiple server, multiple instance
Okay.
of my server to receive the data,
Okay.
correct? So is there any facility for load balancer configuration?
Yeah, Azure will provide the load balancing process and all the things.
So is it compatible with the IoT services?
Yes.
Where you can
I can handle the load balance part also. Any cloud service that okay. So first thing like IoT, when we create a stream analytical job, that we need to select a plan. Right? If we have plan and if a request needs to like per day our plan is 4 leg request on that part. So we utilize only 4 legs. If you want more, then we use this kind of auto scaling process.
so that is by default managed by Azure.
Yes. According that we need to select a plan. Yes. We can do many more things like based on like we have a function Azure function. We can host our services like we have application right. Any application we can host it. We have a different as host it. IoT. What is your question? We can okay. So we have a requirement like if we have this kind of we have more than this temperature, then we need to send an alert. We can also do that based on Azure function or we have a logic set based on that. We can add our IoT hub on that input part, and based on our requirement, we are getting that fields right, temperature field and all the things. So we utilize the temperature field. We can do our requirement. Actually, IoT Hub will be many more service on the Azure will connect with IoT Hub. We can add Azure storage also. We can utilize it. Event Hub. We can connect with the IoT Hub. Many more services are available to connect with IoT Hub. IoT Hub is provide one platform to host the data. So we can utilize many more other Azure services. Okay. Okay. This is the Power BI portal. Those who don't know, like Power BI is a tool that Microsoft has provided for visualizing our data. For our purpose, one quick thing. When I add output as a Power BI part, right? This data set will automatically created on a Power BI. If I delete it, it will automatically create it, and then based on the data set, we can create our report. So for that, I have created a dashboard. Dashboard is just a part that we can add we can add multiple reports. If I want a report, okay. So this when I create a report, first time I need to set a data set. Data set means data. Currently, we have a live data like real-time data. For that, I need to select real-time data like streaming data. This data set is automatically created by a stream analytical job when I add an input in a stream analytical. If I delete it, it will be automatically created. Currently, I have select a line chart. Value purpose, I'm selecting temperature. Okay. As you can see, the chart, the graph will be fluctuated based on our real-time data. Currently, for our purpose, we have a delay of 3 seconds when we send the data. If we don't get, if we don't set any delay on that part, we are getting a real-time data. One thing like I just need to. Okay, so if I don't have a physical device, and if I want to utilize the Azure services, IoT services for that, so Azure will provide a simulator part. In that part, we need to add our connection string here, and then run the simulator. We don't require a physical part for checking our services. Like if I am new to Azure and I want to create that service, but how I know, like I don't have a devices currently, and I want to know if this service is working correct or not. For that, we use this service. That simulator is provided by the Azure, so we just need to set that content connection string and then run the script. We are getting the real-time devices from here also. Okay. Any query on that part? Currently, we have a use case to sense the data of temperature and then send it to one place that we can identify that this is the place that we need to capture the data. And this is how we show the data. So this is our normal use case for understanding purpose. Those who are new to this field. Any question on that part? Okay, so now I will pass it to Jay.
Thank you, Rajat. So now we know how a system works, right? The basic system. It's not that complex. It's not very high level, right? So now we all know the working of a IoT service, the working of a Raspberry Pi. What is IoT? How does it work together? But is it all good? Is it the best that we have? No, right? There are going to be some cons. As the saying goes, take the good with the bad, right? There are going to be some cons while creating a system of your own. But of course, we like to take just the good, right? We don't want the cons. We don't want the bad components of the system, right? But unfortunately, that's not the case. What happens with this is when you create a system where data is being sent somewhere, be it Azure cloud platform or be it some server, right? Of course, there's going to be some risk of security, right? It's not going to be 100% protected. Your data is not just going to be sent somewhere without any issues, right? So, okay. So the first point being security. Now, security can be very crucial if you are working with a lot of IoT devices. But the thing is, I'll give you an example. In 2016, there was a virus named Mirai. Have you heard about it? Anyone? Okay. So what Mirai did was basically send out a Ddos attack. So what Ddos does is basically overloads the server with multiple requests. So it was easily able to break through the simple firewall of whatever enterprise. I think it was IBM, Netflix, and Amazon, right? All these big companies, big MNCs, they were not able to protect their data. But the thing with this is there is very weak encryption when you're sending IoT device data to your edge device or your server or your cloud platform, right? So that's an issue that can be fixed to a certain level, but not completely. Okay. So the next issue being connectivity. Now we're sitting here right now with our device setup, right? We're sitting very close to the Wi-Fi. What would happen if I'm living in a village, right? I'm living in a very remote area. I'm living outside the city, and I have my connection set up. It's my hotspot or my Wi-Fi, right? What if it's not very fast, right? It could be just a simple 1 Mbps or a 2 Mbps plan, or there's some issue with connectivity, right? What will happen is the device will pretty much fail almost every time if there's a connectivity issue. If you're not having a good and very strong connection while sending the data, you're going to run into a lot of problems. Now, this might be configurable here, right? I only have one device, but what if I'm running a company that is basically dependent upon the telemetry data of these devices? What happens then is if I lose connection, I'm going to lose my business, right? And we all know time is money. So if I'm losing out on critical time and critical data being sent to my servers, that's going to be a very big issue, right, in corporate. So there's another con of using these devices. The third issue being challenges in sensing. Now, of course, we have a simple DS18B20 temperature sensor here, right? So what if I change my temperature sensor, or what if I use a ultrasonic sensor? What happens then? The thing is, these sensors are not very debuggable, right? You're not going to write some code into VS Code. You're not going to get red lines of error showing you exactly what the problem is. You're going to have to figure it out yourself. There's no proper process or interface to basically debug this whole system, right? So that's a pretty big issue, because if I'm running into some problem, right? So we also ran into some problems in our development stage. So if you run into some problems, you basically have to do it by trial and error. You're going to have to change the wires, maybe change the sensor itself. So that's a pretty big issue in itself. Now, after all this, is there something that you feel like we missed? Or is there something that you would like to add? Maybe your experience in robotics, right? Using the Arduino. Is there something that you would like to add on? Okay. So basically, I'll just summarize now what we have covered. So we started off with the introduction. We learned about what IoT is. We learned about Mark Zuckerberg's vision for IoT. We learned about how we can use IoT with Azure, right? These were the basic introductory parts of our meetup. In the second module, we learned about configuration. Now, we can also configure this by ourselves, but there will be some issues that you'll have to troubleshoot yourselves. But it's not that difficult, right? You can put in some time and you'll be able to get a result. In the demonstration part, where I showed you the temperature sensor working with cold water or room temperature water, be it, we saw how the temperature will send real-time data, which can be very crucial sometimes. And we learned how that data can be sent using some Python script and creating a basic wiring setup with the Raspberry Pi. Now, in the third module, we learned about IoT with Azure, the core part. What Azure will provide you in IoT Hub as a service itself. What IoT Hub will do is basically give you that platform to create your environment, right? Now, if I'm creating an environment for, let's say, about 10 lakh devices, or let's say I'm creating an environment for just one device, it will do the job. But there are, of course, some configurations that you'll have to look into yourself. Our agenda was to cover it using Azure Cloud Platform and using Azure Iot Services. But of course, there are other services like Amazon or other cloud platforms that will provide you some sort of functionality that is very similar to what we have done, right? So if anyone has any idea regarding that, you can share your experience. Otherwise, any questions? Okay.
How can we make what are the possible areas to make this complex process in a cost-effective way in Azure?
Okay, so Azure is actually slightly cost efficient than AWS and other cloud platforms. What you will definitely need are some jump cables and some basic sensors they are pretty cheap, right? They're in the range from, I think you can get okay, you can get these sensors, right? You can get these sensors for pretty cheap. I think they are 10 or 20 rupees each, right? The bundle. And you can get the chips. Okay, if I want to purchase an Arduino Uno, it ranges within like 700 or 800 rupees. You can get the Raspberry Pi as well. It's a bit more expensive. The Raspberry Pi, you can look into options. There are different variants for it. The one we are using is Raspberry Pi 4B, right? It's slightly better in performance than the Raspberry Pi 4. So I would say if you're building a cost-efficient system like us, it will probably cost you around 6 to 9,000, right? And I'm not counting the Azure services, right? Because that's a different pricing model. Of course, they charge every, I think every bit of usage, or they charge every day, depending on the services, right? So I think we use the Stream Analytics job and the IoT Hub services, and the pricing for about a month and a half or two ranged within 1,000 or 2,000. It depends upon the amount of messages you are actually sending and the amount of data that is actually being transmitted. So that was basically the cost-efficient way of building the system.
AWS has 1 year of free tier.
No, actually, when you are new to the Azure, you will if you are create your own account or sign in, Azure will provide a 1 month trial for that user, and it will give you around 30,000 amount, and use a basic service if you are want to use. And like if you are new to the Azure and you don't know how much, if I use this service, how much I need to pay. So for that, Azure will provide Azure calculation. So when you are creating that part, before that you need to check how much it will cost you if you use them. Azure will provide that costing calculation.
Yes.
Like use the SQL database.
Yes, exactly.
SQL is a paid service.
Yeah.
So is there any possibility to change the DB like MariaDB, Postgres, SQL?
For the stream analytics, we are getting some predefined things on it. For other service, you can utilize it.
Okay, so I'll basically tell you how it works from the start, right? So let's say I have connected my sensor, I have configured all the BIOS, right? The temperature actually will be in raw format, right? The data won't be already in JSON format, or it won't be in a structured format. So the data is in raw form. The temperature sensor will send that data over to the Raspberry Pi in our system, and then the Raspberry Pi basically will execute the Python code that we showed you, where the data will be somewhat structured and it's sent in a JSON format, right? Now, when you're configuring the actual IoT Hub in itself, when you create a new one, right, it will show you an option in the advanced settings where you can actually specify the incoming format, the input format. So if I select, let's say CSV, and the data is coming in the JSON format, it won't be compatible. It probably will show you an error, or it might just not show you anything. So that part is, I think that was the question initially too. How do you understand which data is coming and which data is actually being stored in what format and how it is being structured, right? So the data is actually sent in JSON format, but IoT Hub will intercept that data as it already knows that JSON format is going to be incoming. So, okay. Any further questions? Okay. So that's it. I would like to conclude our meetup for today. I hope we all learned something new. And if you want to look at the actual setup we have here, you can just feel free and come on back. Okay. Thank you, everyone.
Okay, so thank you everyone for participating in this meetup. Okay, I would like to thank our team members. Okay, Jay, Ishan, Himanshu, and Rajat for the informative session. We will conduct more informative sessions further. Okay, so thank you all for the participation. Thank you very much.
Okay, for here you can see Azure